Okay, apologies for the delay. This is going to be interesting because we've had various challenges getting the demos working and so on, so bear with us if it goes a bit pear-shaped. Okay, so my name's Adam Laurie. I have Marcel and Martin here. I'll do some introductions. I'm CSO of The Bunker, formerly known as AL Digital, and co-maintainer of Apache SSL, and one of the organisers of a US conference, which I know a lot of you have been to, called DEF CON. I'll let Marcel introduce himself. No? Microphone.
Oh, is it me?
Okay, Marcel, you probably, anyone who's using Linux, you'll be using his tools. He's the main developer of the Bluetooth stack, BlueZ. Martin Herfurt is a security researcher I met last year in Salzburg, and he started the Trifinite group, which we're all members of, and where we'll be publishing our research. So just this talk will cover a brief outline of Bluetooth. I mean, I'm sure most of you know what Bluetooth is all about, so I won't go into too much detail. Marcel will give some good detail on the actual internal workings of Bluetooth and what's coming. We'll have some history of how we got here to full disclosure, and some more detail on the technology, and then we'll go into various specific attacks, and we'll try and do some demos as we go along. As I say, we have had some challenges with that because we were expecting to have multiple projectors and so on. So it's going to be interesting to see if we can make that actually viewable. Martin has released a tool called Bluver, which he'll be describing in more detail. He also has a technique for trying to determine device types called blueprinting. We'll talk about some DOS attacks we've discovered, and Marcel will go into some details on sniffing Bluetooth, and then we'll go into conclusions and questions and answers. Okay, so basically, Bluetooth is a wire replacement technology. It's designed to get rid of all those fiddly bits of wire, so you can connect your phone and your camera, whatever, to your laptop. It's fairly low power. Published ranges are 10 meters to 100 meters, although, as you'll see later on, we can actually extend that range massively. And one of the reasons is because it uses the same frequency as Wi-Fi, so there's a lot of tools already existing and antennas and so on that we can use to increase that range. Data rate is currently a megabit per second. Bluetooth was created by the Bluetooth SIG, who are basically a trade association. They own and license the IP, and anyone can join. So if you write a hacking tool or an auditing tool or whatever, as a member of the Bluetooth SIG, you can actually use official Bluetooth documentation and logos and so on. So you can actually put the Bluetooth stamp of approval on your own products, potentially. So the different levels of membership needed for different things. So if you want to incorporate a Bluetooth device in a phone, you actually have to be a higher level member, and you have to pay fees to get your devices audited and approved. The consumer site for Bluetooth is bluetooth.com, and then there's a more technical site, bluetooth.org, where you can download specs and papers and so on, and that's where you would go to sign up as a member if you want to join the SIG. And for reasons we'll go into later on, that's a good idea if you're going to get into research. Okay, so history of problems with Bluetooth. The first real unexpected use of Bluetooth was a thing called bluejacking. And in the very early form of that, basically you took your Bluetooth device name, which is normally set to, default might be Nokia 6310, you change it to my phone, whatever. That field is actually very large. You can put up to 256 characters in there. So very early adopters used to change their name to a complete message and then try and send messages to other phones, and so it would come up saying, blah, blah, blah is trying to connect to you. And the whole message would be in that connection string. They didn't have to do anything other than try and talk to you to get the message across. it's now more common to actually send a pre-prepared bluejacking object like an OBEX, a business card or whatever via OBEX. And I don't know if it's the same over here, but in the UK there are various bulletin boards and systems where people go and they exchange stories about a phenomenon that's become known as toothing, which is where you Bluetooth strangers, you send random messages to strangers on a train or in a hotel lobby or whatever, and you set up casual sexual liaisons. And apparently people do this. I don't know if they do it over here, but it's a fairly typical new technology getting used for sex. So. Then it takes off. Everyone starts buying it. Okay, so blue snarfing was the first serious problem that we came across. It turns out that after I published, I learned that Marcel actually published a paper in German at the Wireless Technologies Congress about a month or 3 weeks earlier. And he met pretty much the same response as I did when I published in November, which was, yeah, we don't care, there's no real problem. It doesn't really exist in the real world. So when I published in November, I first started by going to the Bluetooth SIG and trying to tell the security expert group there that they had an issue. After a couple of weeks and some prodding, I'd had no responses whatsoever. So I went public on BugTrack and full disclosure, just with the fact that the problem exists, no details of exactly what the problem was. And again, I got the same reaction. The manufacturers that did bother to get back to me, which was basically Nokia, said, yeah, okay, we think the problem probably does exist, but it's not a real threat in the real world. So I then went and proved it was by going into the Houses of Parliament and snarfing 50 MP phones. We also went on the London Underground and found about 300 phones in the space of about an hour. So clearly it was an issue in the real world. Blue snarfing is called that just because of, again in the UK, there's slang for snarf. To snarf a copy of something is to take an unauthorized copy, so it's just blue and snarf put together. So with blue snarfing we can steal calendars, we can read your whole calendar. If you've got images associated with any entries in the calendar, we'll get those. We can read your phone book. Again, if there's images in there, we'll get those. And what we've found is that a lot of people store other stuff in their phone, like PIN numbers. I've even seen an example where I had the names and addresses of 3 coffee shops, complete with door codes, alarm codes, and safe combinations. So not a good place to put your stuff. Okay, blue bugging was first discovered by Martin, or first publicized by Martin at CeBIT, and he was basically trying to emulate what I had published and again demonstrate that the problem existed in the real world over here in Germany. It wasn't just a UK issue, and he'll go into more detail about that later on. What blue bugging gives you is the facility to actually connect to the serial profile and control the phone, not just steal data from it. So you then have full access to the AT command set. You can read, write SMS stores. You can read and write the phone book. And you can actually initiate calls and so on. Okay, so why has it taken us 13 months to get from first discovery to full disclosure? Normally in the software world, you would expect 6 to 8 weeks, maybe maximum, if you have a problem, and you can demonstrate the problem. It's partly the clash of cultures. That it took us 6 months just to get the phone companies to recognise that A, there was a problem, and B, all we wanted to do was tell them what the problem was so they could fix the damn thing so we can actually have useful devices on our desktops. And they come from a completely different environment than the one we're used to, the open source world and the internet, where sharing information comes fairly naturally to us. They're working in a very closed environment where they control the networks, they control the devices, they control the source code, and they really couldn't understand how someone, or individuals or group of people could be coming along, giving them useful information for free, and not then demanding payment or blackmailing them or whatever. So it took 6 months to get over that hump, as well as presumably there's some fairly serious financial implications for them in gearing up to actually do something about the problem. They're embedded devices. It's not like ordinary software where you can just publish a fix and expect people to download and install it. People like Nokia have to put the production lines for old phones like 6310s back into action, get the code up and running, fix the problem, have a distribution mechanism for doing updates and so on. So that all took time. And because we were having useful discussions with people like Nokia and they were agreeing to do this work after the initial 6 months, we gave them until now. I mean, basically Nokia published the last firmware fix in October of this year. So we gave them that extra time in order to do the fixes. Having said that, the only fix I've actually personally tested is for the 6310i, which they sent me a new phone, and I tested that the current vulnerabilities were indeed fixed. Motorola committed to fixing the problem as soon as we first told them, but we don't know. Again, we haven't had devices being sent to us for testing, so we don't know for sure if they've actually done it. Sony Ericsson have repeatedly publicly stated there is no problem, we fixed the problem, we don't believe in the problem, whatever. If they've still got a problem, who knows? Okay, so at this point I'm going to hand over to
Okay, I will continue. We do a little bit Bluetooth technology introduction. First, raise hand whoever used Bluetooth so far. Oh, that's a lot. Who understand what's going on? Okay, fine. Okay, Bluetooth is, as Adam mentioned, Bluetooth is a wireless technology. We have data and voice transmission, especially headsets, audio transmission and so on. And it separates between HCL for data connections and SCO. SCO, or the company from wherever. eSCO channel stands for extended SCO channel, only a little bit more bandwise. We have symmetric and asymmetric connections. And as Adam mentioned, Bluetooth uses some kind of frequency hopping, ISM band at 2.4 gigahertz, 79 channels, and it hops very often. That's important. It changes between the 79 channels 1,600 times per second. That is good because it's hard to track. Multi-slot packets, yeah, it uses some kind of, we go over to the next 2 packets on the same slot to increase the bandwidth. Bluetooth, I will use this microphone. Bluetooth uses Piconet. They introduced the definition of a Piconet, and a Piconet is simply, has one master and up to 7 active slaves. But it can have more passive, means sniffed, parked, or other slaves that can be part of the Piconet but are not active transmitting any data. In general, in practice, it is not possible because the chips have not enough RAM to store all these connections. So, generally, if you have a chip that can maintain 7 connections, it's a very good chip. I have spoken about the hopping sequence. Actually, the master sets the hopping sequence. So the master defines the Piconet, and the Piconet is defined by its hopping sequence. So the master is gone, the Piconet is gone. The transfer rates actually are at 721 kbit. This will change, or is actually changing in the future, because speaking of the upper part, it's the Bluetooth 1.1 specification. We have the 1.2 specification at the moment with devices out there. Especially Apple really forced it on their iBooks and PowerBooks. And 1.2 really means they added adaptive frequency hopping. Adaptive frequency hopping means they change the channels to be nice to wireless LAN or other wireless technology that operates in the same bandwidth. So Bluetooth is nice to other, while the other one may interrupt the transmission of Bluetooth connections, but in general it hops so fast that if you have a blocked channel, it doesn't matter. EDR stands for Enhanced Data Rate, also known as Bluetooth 2.0. Actually, it's a marketing gag. It should be 1.3, but they think it's naming it 2.0 makes it even better. It is not so, but Enhanced Data Rate increases the transfer rates up to 2.1 megabits, so increases 3 times, which is important for audio transmission and some other things they have in mind, so video transmission also, but actually even 2.1 megabit is not enough for video transmission. So I've spoken about the Piconet. What we've seen here, this is a simple, This is a simple Piconet. One, we have a master, we have slaves that have connected, we have parked slaves, maybe, maybe not. And if we have one device that is master in one and slave in another Piconet, we have a scatter net. This can also be slave in one net and slave in one Piconet and slave in another Piconet. But you cannot be master in one Piconet and master in another Piconet, because it's the same Piconet. Because the master defines the hopping sequence, the Piconet is defined by the hopping sequence, and so it's the same Piconet. What's interesting is the scatternet support is optional by definition of the Bluetooth 1.1 specification. It's kind of weird. The devices should support it, and mostly at the moment, all devices on the market supports it. Okay. So, a little bit out to the stack design. This is the initial stack of the Bluetooth 1.1 specification. It has not really much in it. It grew a lot, and we have many other profiles, but I will go through it. We are on the lower side, we have the Bluetooth radio, a simple thing operating at 2.0 gigahertz. The baseband, actually transforming the radio waves and changing them into data. And we have the link manager. The link manager is for creating the connections between two devices, really creating the lower connections. And we have the audio part is always some kind of around it, because for audio you need low latency and some other fancy stuff to get around. It not really fits in the stack diagram, so we leave it there and state it as is. These three form a Bluetooth dongle, or a Bluetooth module, or a Bluetooth chip, wherever. This is hardware, every of them. And then we have the HDI, host controller interface, which is the connection between the hardware and the software stack running on Windows, running on Apple, running on Linux, or even running on a mobile phone or other embedded device. Every security functions that are included in Bluetooth are included in hardware. We don't do any encryption, any kind of fancy thing above the HDI. The HDI simply asks, oh, I need a pin, you give it the pin, and the hardware do the rest. I'll come to that a little bit later. Over the HDI, we have an L2 CAP, logical link control and adaptation protocol. It simply has a MTU, segmentation and reassembly stuff, and so on. It makes operating with the small packets that are generated by the baseband very easy, and gives a nice interface up to the higher layers. The L2 CAP is based on everything that's data transmission. The audio transmission are a little bit different, but everything that's based on data transmission goes to the L2 CAP. So it's one general layer above the HDI interface that abstracts them. That is good. But besides that, they started to put stuff above it. One mentioned is RFCOM. RFCOM is derived from ERCOM, from the RDA specification. It's emulated serial port. The TCS stands for Telephone Control System with a protocol that is mentioned, TCS binary. It is for enabling some kind of using DECT over Bluetooth. It's not really DECT, but it's the same. It's for home-based phones, so you can use them and attach them to an access point, and they are like a base station. They can communicate it like a base station. On the upper right, SDP stands for Service Discovery Protocol. That is a general protocol that allows you to, oh, I see you, you are my device. What service are you supporting? Okay, what can you do? Can you emulate a serial port? Can you be a phone base station? Can you? Why nobody says things? Okay, I speak too long on this slide, I think. And on this level, there are many other protocols. I come to that later. BNAP for the Bluetooth Network Encapsulation Protocol for transferring TCP/IP. AV-DTP, audio video distribution for distributing audio and video. I said video is not really possible because the bandwidth is too slow. But if the bandwidth increases, the protocol is already defined. They simply have to use it. And this part is also Bluetooth specification. Everything that is over there is some kind of the adapted already existing protocols like OBEX for object exchange, vCards, calendar entries, and so on. In the beginning, they thought putting PPP with TCP/IP over ARFCOM, emulated serial port, is a good idea. We know that it is a bad idea, but they did it that way. And of course, we have AT commands to dial up with your mobile phone to the internet like you do with a cable or with an infrared connection. I already have on the slides the security stuff. As I said, the security mechanisms on the Bluetooth chip, hardware, the Bluetooth host security mechanism that are actually part of the Bluetooth host stack, and application-specific security mechanism like SSL, TLS, and whatever, SSH, whatever you can think of. This is not covered in this talk. This is also not covered in this talk. We will talk about this a little bit. The link manager security. I want to split out some rumors. Even if you see a pin code going on in the later in the presentation going on in clear text, it is never transmitted in clear text over the air. It's out of topic for this talk, but it can be stated in so many papers on the internet that can be found. They do the stuff a little bit different, and this is never in plain text. The host security interfaces to the link manager routines that are brought up by the HDI. They are very simple routines we will later see, and they are easy to interface, but we will also see that some people or some companies can implement them wrong or use them wrong. It's part of the HDI specification. I said it's an easy interface. On this level, we have no further encryption of the pin codes or link keys or any other security related things, so there you will see a clear text pin. Bluetooth defines 3 different security modes. Security mode 1, no active security, means, yeah, okay, we connect to that device and there's no encryption, there's no authentication, there's no authorization, there's nothing, we simply connect to it. Sometimes it's nice, sometimes we really want that. For example, okay, I want to send you a business card. Why should I authorize, why should I authenticate, why should I encrypt it? Yeah. You only, a vCard you gave written on a paper, you also put it in an envelope and send it via postal service somewhere, you give it over. Security mode 2 is defined as service level security, and actually it is from the device. When you look at the Bluetooth device or the Bluetooth module or the chip, it is no difference to the security mode 1, because the security modes are clearly specified that they have to, if one side uses a higher security mode, the other side have to follow. So if you are in security mode 1 and the other side means, okay, I'm in security mode 3, then the side has to use security mode 3. And security mode 3 is the highest one. It's this device level security. This means that actually every connection, low level connection from the link manager is secured by authentication and encryption. On the service level security, it's based on the service that is running. For example, pushing a vCard to another device is not secured. Reading the phone book from another device, as Adam mentioned, should be secured. Little step in Linux and Bluetooth, because we will use it, and if you plug a Bluetooth dongle on into Linux, you simply, it will work in most newer distributions, and you can call something like ifconfig, named HDI config, and you see your local device. You see the Bluetooth device address. A Bluetooth device address is the IEEE address, like your MAC address of the Ethernet card, and states up, running, pscan, and iscan means page scan, and inquiry scan. Inquiry scan means it is discoverable. You can, if other devices search for it, it will announce it to them, and page scan means it can be connected. This means other devices can connect to it. You can set it non-inquirable and non-pageable, then it's totally invisible and should not be contacted by other devices. Which means if you use your mobile phone and switch Bluetooth off, it can either switch Bluetooth completely off by deactivating the chip, which is the best idea to save power, or it can set to no page scan and no inquiry scan. Simple other stuff, we have some features. There's a list of 8 bytes, which defines what this device can really do. For example, it supports scatter nets, it supports this enhanced feature, and so on. Different packet types, I won't go to that in detail. They are simply, in general, there's a normal rule, activate all packet types to get the best throughput. It has no really sense to disable them. The link policy is interesting because it talks about role switching, hold, sniff, and park mode. Hold, sniff, and park are power save mode to save power, because Bluetooth is a low power technology and should give you as much battery as possible. Role switch part is, okay, I'm the master of the Piconets. The master of the Piconets initially is the device that created the connection. Sometimes that's bad. If you connect to an access point that have more than one connection, okay, and then the access point should be the master of the Piconet, but you created the connection, okay, then you switch the roles as possible. It is a slave device, it accepts connections. It has a name, of course. You can see it if you scan through it. It has a class of device which is decoded later. It supports general class and network random capturing. I simply said almost everything. Oh, it's a computer. It's n-categorized. Maybe that should be notebook. And there's a chip manufacturer defined by a number who really builds these chips. Actually, I think there are 60 listed, but I've seen only 10 different chip manufacturers. This was a Bluetooth 1.2 device. I've seen 2.0 devices already, but yeah, sometimes we'll display 1.1. So this is simple. If you plug it in, you can look at it, and you can also change the settings. Very easy. If you now have a working device, it's up and running, you can scan for other devices. Simply type HDI tool scan, and it starts scanning, and it finds, again too long for this slide, it finds the Bluetooth device addresses of the devices in your surrounding, 10 meter or 100 meter, depending on your antenna, and then it tries to resolve these names. This is an example. You can do this live later on. I think Adam will do. You will do that. I will continue a little bit about the sniffing with Hdi Dump. Every tool has the name HDI in front of it because it's based on the lower level HDI. We have some other with L2 cap and so on in front of. We can record every HDI packet that is going to the chip. This is nice, so we can really see what's going on. What we cannot do is see what's going on the chip. So a link manager, baseband, and radio can sniff, not with normal hardware that's buyable everywhere. It is possible with called Bluetooth protocol analyzers, but they cost around €10,000 or $10,000, $15,000. They're really expensive. They don't have to be, but they keep the price very high. HDI defines itself only 4 packet types: commands, events, HDL data packets, and SCO data packets. Commands go from the Bluetooth protocol stack, from your PC or your mobile phone, to the Bluetooth chip. The events come from the chip up, and the data packet and SCO packets fly in both directions. It can only decode local connections. It's important. If you're not part of the Piconet, you can't sniff a Piconet. So if Adam and Martin create a Piconet and I create another one here, I can't sniff what they have. I need a protocol analyzer for that can synchronize with the hopping sequence of their Piconet. We get all data packets, so we also can decode the higher layers. HDI and L2 cap, very easy. The layers above, Service Discovery Protocol, SDP, RFCOM for the emulated serial ports, BNAP already mentioned, Bluetooth Network Encapsulation Protocol. Over Bluetooth Network Encapsulation Protocol, we have raw IP traffic, IPv4, IPv6, IPv4, IPv6, and IPX also is defined, I think. I haven't seen anyone using it. We have CMTP, stands for CAPI Message Transfer Protocol, which means we put CAPI over Bluetooth. Simple ISDN, very popular. Only one company manufactures it at the moment, is AVM from Berlin, but Linux supports it already. HIDP stands for Human Interface Device Protocol, which means, okay, we can also use a mouse and keyboard or a presenter if it works. I don't know why not. Simply have mouse, a keyboard, or whatever pointing device attached. It's related from the USB HID specification, and it's the same powerful as a USB one. HCRP stands for Hard Copy Cable Replacement Protocol, means replacement of a parallel cable for printing or scanning. And we have AVDTP, I already mentioned that. Audio video distribution profile means high quality audio, CD quality audio, and also video. Video is defined, but with the current bandwidth not really usable. And then we have the adapted protocols, OBEX and CAPI. They're also decodable. More to come. If somebody has fun writing a new decoder for it, it's very easy. And actually, we only support this protocol at the moment, and so the only decoders exist for these protocols. As I mentioned, no sniffing of baseband or radio traffic. I'll go over a little bit to the security stuff. As I said, we have HDI commands and HDI events. The simple commands are, these are not so important. There are some general settings commands, unique keys, pin types, stored link keys. Interesting is authentication enable. Authentication enable means we set the device to security mode 3. And encryption means we also set in security mode 3 and enable it. As I said, there's no difference between security mode 1 and 2 if you look at the device. So it is security mode 3 or it's not security mode 3, only if you look at the device and you use these 2 commands, or actually 4 commands if you want to read them, to set that. Interesting, these lower 4 are events. Oh no, sorry, there are also commands. You can also request an authentication at any time. You feel, okay, I don't trust this device anymore, let's authenticate. You send simply down to the chip, authentication requested, and you say, okay, give me the authenticate me. You can also set the encryption at any time. You also can set the encryption off. It makes no sense, but it's defined in the specification, because the encryption is almost at no cost, and simply if once it's active, you should never deactivate it, but it's possible. You can change the local link key. We will see what the link key is and what the pin code is the difference. And you can change the master link key, which is some kind of stupid commands. They had some weird ideas when they started with Bluetooth. In the end, it came out that some of the commands are useless, but they are in the presentation for completion. The pairing functions. Normally, if you have 2 devices, they generate some kind of trust. So they have to pair. The pairing has 3 events. HDI link key notification, though the chip sends you, okay, this is a link key for this connection between these 2 devices. It's 128 bits. The chip cannot say, okay, I need the link key because the other side requested it. Please put in the link key that you have received via a link key notification the previous state. Okay, nice. And, okay, we don't have any link key. Maybe you put in a pin code. So the pin code can be a fixed pin code that is programmed on the flash or on the EEPROM or whatever, or it can be a pin code that is entered on both sides. So it's a random number up to 16 bytes. If these events come from the HDI up, you have to enter them, and you simply enter them with link key request reply. Okay, I give you a link key that I know, that is a link key. Or say, I don't have a link key. I don't know what to do. The other side decides, okay, then give me a pin, or you don't have a link key, no, go away. The same for the pin code. So, how pairing really works? First connection. We have 2 devices that have never seen each other. They're set to discoverable, and then, okay, connecting, okay, I've never seen you, I don't know you, I need a pin code. So, we get the pin code request. Okay, we send down the pin that we mind, 4 times 0 or 16 times 0 or a total random number of characters and numbers, which is good, but okay. And then we get a HDI link notification, and then we have the link key. That's the first connection. After that, everything is fine. You are connected. If you requested the encryption also, then the connection is encrypted. And yeah, okay, then you disconnect. Fine. You don't need this mobile connection anymore. And then maybe a day later you connect again. This time it comes up, okay, we already trusted each other, but put in the link key. Okay, you put in the link key. And then that's it. They have the link key, they are shared. The link key is also not going in plain text over the air. I want to mention that again. And if there are some new devices try, okay, we have a link key exchange now, we know that we are trusted, we can go on, but let's generate a new link key. They call create new link key, and then they got a new link key for this connection for use the next time. And this go on and on and on. So the pin code is only needed once, and if it not use a fixed pin, you can put in any some numbers and nobody cares. the link key is the important thing. If you know the link key on both sides, you can sniff the connection. Otherwise, it's very hard. I think it's nearly impossible. It's nearly impossible to sniff the connection between in a Piconet if you don't know the link key of the corresponding device, of the member of the Piconets. That's so far. I think I hand over to Adam. Any questions so far? That's some kind of important for the rest of the presentations. Okay, please. Microphone.
You said that these Bluetooth analyzers are very expensive and they didn't have to, but they do not have to be so expensive. Is it possible to build something like this on your own?
On your own? Yeah, of course it is possible. Actually, I can't do it. There are certain different kinds. Normally you take only a radio chip and sniff every traffic on the air, and you have to follow the hopping sequence, the Piconet establishing. So you have to synchronize with the Piconet, but you are not being an active member of the Piconet, so you can't request any retransmission and so on. So if you lost one packet, it was really hard. There's some hardware from the CAT seats now bought by another company, I don't know its name. They built a really good protocol analyzer. I think it's 10,000 euro. There's also some kind of easier way to do it. If you have access to the firmware, the link manager is firmware, while the radio and the baseband is really hardware. If you have access to the link manager firmware and you modify the link manager firmware to sniff with it, you can use a simple dongle, Bluetooth dongle for 50 euro from whatever, and put a specialized firmware on it, and then you can sniff with it. It is done. Companies are selling it, but it's not cheaper. They sell it for 10,000 euro. Because the software that they use for displaying the sniff ducts, that's the expensive thing. Yeah, what should I say? Should not be, but...
So somebody has to implement it as an open source, something like that.
Yeah, maybe an open source Bluetooth design, complete design from radio baseband to link manager will help, but I haven't heard of any project starting that.
Okay, then someone have to start.
Feel free.
I have
Contact me afterwards.
Another question. You said that this key is with 128-bit encryption. With algorithms are used?
It's a safer plus used.
Ah, okay.
Any other questions?
On that point, it might be interesting to look at software radio Bluetooth implementations that are coming along. They might be easier to get in at the baseband that you need to sniff other traffic. So.
Yes, I would also have a question, and I would like to know, do I have to, with this protocol analyzer, or with a Bluetooth analyzer, do I have to sniff the complete peering process when I want to sniff the traffic, or is it possible to sniff, yes, normal traffic, and also then I would...
If the traffic is not encrypted, then it doesn't matter. If it is encrypted, you need the link key. If you don't have the link key, you have to sniff the pairing process. So you have to see the initial pin request. Mm-hmm. If you don't see it, then you can't decode. You see the traffic, but you can't decrypt it afterwards. I think brute force maybe work, but there are some calculations that it... what do you know?
Well, I think Ollie Whitehouse published a paper where if you witness the pairing process, you can brute force the pin, and once you've got the pin, you can then get the key, and then you can sniff encrypted traffic.
Yeah, I think,
but you do have to witness the pairing.
Yeah, but that only works if you see the pin. If you are at the second stage, before further connections, it's already too late because you have to input the link key. If you're in the first stage with a pin code, you can sniff it. There's some calculations. If you use a 4-byte pin, 4 characters pin, and you know, okay, it's a mobile phone where you normally only have numbers to input, then you can brute force is in between some hours or so. If it goes, I think it's over 8 characters, then it takes you 200 years or so to brute force it, even with really high-speed machines.
So I have to, basically I have to sniff the peering process and then brute force the pin number.
If you have the peering process with the pin, you don't have to brute force the pin. You see everything you need.
But I thought the pin wasn't transferred in plain text.
Right, but you see both sides, and then it's fine.
Ah, okay, all right.
Look at Ollie Whitehouse's paper that was published at CanSec West last year. It's the at-stake paper, and that covers that whole subject.
It's very interesting, that paper.
Yeah.
Even the calculations in there, I can't remind them. Would you continue?
Okay, so now we get to the first bit of meat.
Could I ask one more quick question? Sorry to interrupt. Would you be able to give some sort of indication of the size of the field hopping sequences that defined a Piconet?
What do you mean by size of the hopping sequence?
Sorry if I misunderstood, but I thought that the Piconets were defined by masters.
Yes.
That defined the frequency hopping sequence. What field space size is that frequency hopping sequence? Do you know it all?
I didn't mention that. Every Bluetooth device has a clock.
Yeah.
And the hopping sequence is derived from the Bluetooth device address and the clock. And if you connect to another device, they synchronize their clocks. And from that, the hopping sequence is determined.
Thank you.
You're welcome.
Okay, if there's no more questions,
Hang on.
we'll do more later.
You told us about to switch off the Bluetooth, you either way have to deactivate the P-scan or I-scan, or you just turn off the power to the chip. Now, if I just deactivate P-scan or I-scan, am I still vulnerable for attacks, or what happens?
If you deactivate the I-scan, you're invisible.
Okay, I'm invisible, but if someone knows my address...
You are still connectable.
Okay.
If you deactivate P-scan, you are not connectable anymore, and there should not be any possible attack. If the chip itself has a malfunction or is not fairly implemented, we have seen that you switch it off and it's still, if you know the address, you're connectable. But that is a wrong implementation of the chip. If you set off P-scan, you are not attackable.
Okay.
But
Yeah,
you could still consume power.
And if L2 is still available, then potentially you're subject to DOS attacks. We have actually seen phones where in the menu Bluetooth is switched off, but we could still crash the phone by sending DOS attacks to that address. So we think probably they're using a software radio implementation, and the underlying stack is still receiving the packets, even though the menus say that the Bluetooth functionality is off. So. It was a pre-release phone, which I don't know if they fixed it before it got to market, and I can't remember, but it caused a bit of a stir in a room full of telcos who were trying to basically screw me up by saying, you're not going to be able to do anything now, go on, attack this phone. And you should have seen the guy's face when it crashed, because he thought he'd turned Bluetooth off. So, okay, so the first of the full disclosures, BlueSnarf, turns out to be an utterly trivial attack. Basically, you use the OBEX push channel, and instead of pushing, you pull, and that's it. You go to the infrared, the IRDA Association specifications, and have a look at the IRMC specification, which defines specific mappings between objects within OBEX to actual stores on the devices. So they have a device, a store called telecom/pb.bcf, which is the full phone book. You shouldn't be able to read that in normal operation unless you're a trusted device. But on some devices, they've poorly implemented the OBEX stack, and it is possible to just connect to the phone and pull that data. And those are the affected models, the Ericsson R520M, T39, T68, and the Sony Ericssons. The T68i is only vulnerable when you switch it into 3 minutes discoverable mode. But all these other phones can be left fully discoverable. So if people are walking around in discoverable mode, then they're permanently vulnerable to those attacks. And I was going to do a quick demonstration. This attack I've only got working on FreeBSD. No doubt there are tools available under Linux that will do the same thing. But I use a program called OBEX app under FreeBSD, with some shell wrappers that I've put around it. So I'm just going to connect to my BSD box over there. And we're going to play with a camera here, so we'll see how well this works. Okay, so I have a script which I'll run.
You're not typing anywhere, it's terminal.
Sorry, not my laptop. So in the first instance, I'm just looping. I'm looking for devices. Well, I'm sure we'll get some interesting names here. Can you just match them? Okay, so suspecting this would happen, I'll... what do you do? Bigger font.
The font bigger. How do I do this in a GNOME terminal? As an X terminal. That's a GNOME terminal.
Pretty readable to me.
I have no idea how to make this bigger.
It's not very important. You won't see much detail. Yeah. Okay, so I knew I'd never find the thing in the room full of hackers, so I've already put in the address of this phone that I'm going to attack. Can we try and fire up the camera?
Try to start the camera.
Our camera broke, so we had to go to this shop on the corner and buy this thing about an hour ago.
Oh, I don't forget to install the kernel module. It's a well-known PVC Philips camera, so... Where did I put the driver?
Use Steam again.
Okay. There it is. Oh, come on. No. Feel free to help me with the kernel module name of the video for Linux system. So, finally, there should be a picture. Okay.
It's not that important.
We try for an next attack again.
Okay, so what we were going to do is just show that there's no paired devices on this phone, and then connect to it. So what I'm doing now is I'm running the same script, but this time instead of going for information only, I'm telling it to attack a specific address. So it's going to go and look. It's found the phone. This phone's called Knock Knock. And it's now connecting to it. In a room with a lot of devices, this might actually be a problem. So anyone who feels like turning their phones off and making our lives easier, please feel free. Okay, so it's managed to connect. It's now copying. What the script will do is it tries each object individually. So if something fails, it will go around the loop again and it will try that object, and it will keep trying until it's got all the possible objects from the phone. So in this case, it's having problems reading the phone book, so it's going to keep retrying the phone book. When it's done that, it will try the calendar, whatever. So sometimes you have to go around 2 or 3 times before you get everything. But you can have this running on your laptop, over your shoulder, just walking around. And in places like the Houses of Parliament. And all we've got, if you could see the phone, what you're seeing on the phone itself is a little display which basically says connecting. It doesn't say who it's connecting to or what it's going to do, it just flashes up. So if that was in your pocket, it was lying on the desk, you wouldn't see, you wouldn't necessarily notice. Now normally it would have worked by now, so I think we've basically got a problem because there's so many devices in the room. See what we've got.
Only a very short question. You said that this little icon is on the display of the mobile phone. Is it interruptible if you notice it?
You can hit cancel. It says connecting. You can hit. I mean, I think the phone has crashed for some reason, so it's not doing anything. I'll power cycle it. But anyway, in the meantime, we've got the business card, we've got the calendar info, we've got device info. If I look at the device info, what we've read out is some model information. The serial number is actually the IMEI, so what used to be used in phone cloning. I don't know how useful it really is these days in GSM networks, but...
Try mine, Adam. You can actually disconnect with a Nokia phone. So there's a menu entry, I can say, oh, there's a connection, that's the active connection, and you say disconnect, and you connect it, but you must know that your some is connected. Okay.
Sorry, the question was, how do you identify the objects or the phones you want to attack?
Thanks.
I mean, if you're going for collecting data, or you want all the details of all the MPs' phones in the House of Parliament, for example, you don't care which phone you're attacking. You just attack them all. You walk around until you've got everything, and then you go and collate the data afterwards. I don't particularly care whose phone I got Tony Blair's private number from, as long as I got it. So I'll try that attack again. I've put the phone right next to the machine that's doing the attacking, so maybe that will help.
It's connecting.
No, somebody's sending me stuff, so yeah.
How do you know the names of the objects which are going to be retrieved? Oh, I'm sorry.
Oh, well, yeah, that was covered.
I know they're standardized. You have like pb.vcf, etc.
Yeah.
So you just have to ask for them. They're the same on every device.
Exactly. That's what the IRMC standard tells you, is the names of the objects to pull from the device. There may be other things. Okay, so it's now actually successfully pulled everything. So I now have the phone book, the calendar, and so on. So if I look at the phone book, there's all the business cards in the phone, nicely sanitized, so don't bother ringing them. So that's snarfing, and that normally if you're in an environment where people aren't deliberately sending you messages and trying to screw you up, and there's not a room full of weird phones with long names, it happens a lot quicker. So. Okay, so the other attack I was going to show you is, where's your presentation, Marcel? So that's blue snarfing. The Motorola's are vulnerable to a similar attack, but they require, you can't actually use the OBEX channel to do the attack. What you do is you connect to the RFCOM channel, but you use OBEX to soften up the phone. The initial connection will fail. It will correctly ask you for authentication. So what we do is we use OBEX push to create an entry in the device history, which then allows connection to the hands-free or the headset channels, because obviously a headset that you've seen before can be trusted because it's only a little headset, it's only got one button on it. What can it do? You know. So sorry, foreign keyboards. So if I, with Motorola's, it's only vulnerable for, I think, about a minute when you first switch it on, or when you make it discoverable. So I'll first just check device history is empty. So basically I've got, just looked at the device history, it says there's no one in there. And I will go into setup mode. And make myself discoverable. So if I run this again, it's just a script, Moto serial. It will run HCI tool and scan for devices that are visible and report the serial numbers, or the BD addresses, and then I can attack a phone. Okay, we could be here all day, so I think I should have one in my history. Or maybe not. Damn it. Okay, now I'm sorry, we're going to have to go through that. Okay, so this phone is called Moto Snarf. So if I try and attack that phone, is that right? 60832. Okay, we were debugging earlier, so there's all sorts of random crap in here. Okay, so it's correctly come up with someone's trying to connect to me, do you accept or deny? So I'm going to say deny, because obviously I don't know who the hell's connected to me in here. So now I change that to Hello, Moto. So what that's doing now is planting an entry into the device history. So it's just come up saying, connected, incoming transfer, failed, cancelled, and it's gone away again. If I now run that again, I love it when a plan comes together. Okay, so I believe most of the current Motorola's are vulnerable to that attack. So, over to Martin.
So, to mention that up front, the logos you see on the following pages are subject to a brand violation that the Bluetooth SIG flagged like 2 weeks ago, so they have to disappear from the pages by the end of December. Just mentioned that. So as Adam said before, the first presentation of the Blue Bug happened in February 2004 when I had to do a presentation about a very boring topic about war driving, and I intended to spice that a little up with presentation of something I just read. It was Adam's experiments with Blue Snarf on Slashdot. So I tried to figure out how that all worked, and since there were no purpose-built tools available, I had to play around a little, and I found the Blue Bug, which is what you just saw for the Moto or the Hello Moto, but this is done without having to plant an entry, because, wait, it's... So there has been a field trial at the CeBIT. We had a booth close to the restrooms. So our booth was not very interesting, but since there was the restrooms right around the corner, many people came there, and even policemen came there. They left their phones and their bikes, and we snuffed them. And this report got on Slashdot in the end of March. And shortly afterwards, Adam was coming to Salzburg and we teamed up. And what you see here is the results. There have been various media citations. And finally in August or the end of July, we were presenting this work at DEF CON in Black Hat. And we are doing a full disclosure now in the end of December. So, what's the facts about Blue Bug? Oh. Business card, thanks. Another one. So, it's based on SAT commands. As you saw them before, they are quite mighty. They are very common for the configuration on the control of telecommunication devices for a long time. They got enhanced every now and then for every new features. So you have a quite high level of control for call control, sending, reading, deleting SMS, reading, writing phone book entries, setting forwards. And this can get really bad. I show that afterwards with the Bluver. And you actually could cause costs on the vulnerable phones. And I think this was the point where the manufacturers were concerned about, because there's a measurable damage done to the people having these phones. So they got anxious. So how does that all work? It's not that Bluetooth as a standard is not secure. It is that various manufacturers poorly implemented the Bluetooth security mechanisms on their new devices. So everybody knows there's a high competition in the mobile communication sector. People pushing out phones without really testing them. So what happened is that it is possible to connect to an unpublished service via the RFCOM, but this service is not announced via STP, so you won't find an entry in the STP database when you do a browse with a BlueZ utils. So what you do is you connect to the unpublished service without pairing. So there's a little headset symbol showing up in the display once you did that, but then you can issue AT commands doing all what you want to do. You could even get connected to the internet, do it all. It's nothing new to you as your experts. So it's quite a lot of models, and it's funny because there are quite a lot of similarities because it's the same models for the blue snarf. It's not exactly that all the phones being subject to the blue snarf also exploitable by the blue bug, but there's a high similarity in the models. So at this point I wanted, oh no, there's no demonstration for that. So another thing that evolved from the work with Bluetooth is Bluetune, and it's just a funny name for enhancing the range of a Bluetooth dongle. It's been done before by pen tests by Mark Rowe and Tim Herman. They were modifying, what's it called? Linksys? No. This is a Linksys dongle, which has an external antenna already, so it's easier to solder this out and connect a cable for an external antenna which is directional. The original idea is from Mike Oatmusgreen, and he is the author of the book Wi-Fi Toys. I met him after DEF CON, and we were doing that long distance attack, which is on the following page. So what we did here is, it went through the media, maybe you read about that. It took place in Santa Monica, and we were standing up there to the right, that's Mike, and the attackers were down at the pier, which was about 1.78 kilometers away from us. So maybe you're familiar with the different Bluetooth classes. It's not supposed to be like that. It's more than ever. So that it was possible, we knew that before, but that was an actual proof. So it was a full-fledged attack from that high distance. So the next thing I want to present, it's been announced in the report which has been published in the beginning of April about the field trial at CeBIT. So I thought it would be funny to have this attack ported to a mobile device. And in order to be fully correct with the brand regulations of the Bluetooth SIG, the Bluver is called the Bluetooth Wireless Technology Hoover. And please note that the Bluetooth has to be written differently because it's a word mark, just to let you know. It's a proof of concept application, which is for educational purposes only. A phone auditing tool, and it runs on Java. Because it's just that a lot of phones now support J2ME MIDP Profile 2.0, but there's an optional feature which has to be implemented on the phones. This is the Bluetooth API that allows the access of the Bluetooth interface from this Java virtual machine. So this is optional, but on the following phones you have that implemented. It's a Nokia 6600, Nokia 7610, you can read it yourself. These phones have it, and we didn't test it on all of them, but it's quite working on the P900, for example. It also is working, but not on all of them. Adam's phone rejects to install it, but on the other one I tested it worked well. So maybe another bug, I don't know. So what does Bluver do? It is basically performing the Bluebug attack, since it's not very complicated, even with Java, to open a RF connection to that channel 17 on vulnerable phones, and you're just issuing comments then. And this Bluver has some configuration. Maybe Marcel is trying to get that camera working, so I could do a demonstration. That would be nice. And yeah, I entertain you. Just curiosity. How many of you do have a phone where Bluver would run? As far, okay. The Bluver application is available on tryfornight.org, but please use it responsible. got it right? Oh, that's perfect. See that? See, the camera is mirrored. It has a mirrored picture, so I know there's a lot of Apple users out there, so just think different, right? So what's happening then? I have two phones in my pocket which I switch on Bluetooth now. So I became a little careful. Oh yeah, that's
Okay.
no.
What is scanning?
We actually attack a phone that belongs to us, which I now have to enable Bluetooth. So,
I must try to get a shot.
yeah.
Hello? Oh, the light is on.
Oh, okay. Dennis, 6310. No, it's working. Come on.
Look there.
No, I see it here, and just focus a little more. It worked before. Oh, it's double. You just flip it. It's double mirrored.
Okay.
No, it's not. Oh, is it?
That's better.
Did you ever consider a career as a proctologist?
Oh, as a what? Wait. It's stuck. For what?
I think the driver is a simple bug.
Okay.
If you focus too much, it crashes.
No, you have to focus, otherwise it's not
Forget
getting
it.
clear. Hey, not okay.
The camera is there, and still.
But Dennis, you owe 6310i. Are you here? Yeah, switch Bluetooth off or make it invisible. It's not a good thing to have, except you have the new firmware version, do you? Okay, very good. Everybody, I would encourage to do that, to go to the Nokia Care Center and tell them to upgrade your phone. Actually, for the older phones I have, it's not for free. Unfortunately, because the 2 years of warranty already exceeded. It is for free. That's a good news. Okay, I repeat it. So I just learned that if you say, hey, come on, this phone has security issues with Bluetooth, they will do it for free. And which is a good thing, I guess.
I don't get it any better.
Okay, so Marcel is doing a really good job here. So you're into getting the...
It's still scanning.
It's still scanning, so there's a lot of devices here. And one of the devices should be Dev Target. It's the one over here. Yeah, switch it on. So please leave it alone for a little moment. You guys, as you know now, what the name is. Yeah, I will stop it. There you have the options, and you can read anything, right? And it says stop, so I stop it and have the list, and we'll see. Oh, there it is, the Dev Target. You don't see it, but it's a phone to the other hand. Just okay. Oh, this is not really working well. So I just hit it, and Java is asking once if it was okay to use the Bluetooth interface, and you say yes. Oh, application error. See, as Microsoft is releasing software that is buggy, we thought we can do that as well. So, yeah, try it again.
Actually, it says attacking.
It says attacking, but it's not doing the attack, so I tried on my phone. Or probably we should cut that out, because there are some versions of the 6600 which are not as they are supposed to be. I had to have a firmware upgrade on this one to have it all completely as standard implementation, because you know it is specified it's going to be that way, but in the end, if you use the function that way, it's not working out as it should. So that's right, yes. Even if it's a Symbian. So actually, I switch back to the presentation. And yeah, the setting call forward, I want to point that out since it is not really nice to do that. So you can configure your attack. You have some checkboxes. Okay, Aquo date, get you. Snuffed me. Okay, I'll switch it off. So, setting call forward is done by Bluver, but is not nice. So I defined a number here which is not changeable by the configuration dialog. And this has been done because it's not nice to make people pay for your gaming, right? And what happens there is that if anybody tries to call that phone where the call forward is set immediately, it will end up like, okay, the number you have just dialed is not connected to any phone. See? And the person calling this phone is not even noticing it, that this has been a call redirection. And the person owning that phone is not even knowing that somebody tried to call. So this is really bad because you can knock out business phones really easy. And initiating phone calls is unfortunately not working too well on Nokia phones, but on some T610 from Sony Ericsson. This is also a predefined number, 0800. It's a German number, so you might find out what it is by just calling it. It's free of charge. Somebody knows it? I heard a laugh. Are there any Windows XP users? So the next thing, blueprinting, what is it? Blueprinting is fingerprinting, Bluetooth, wireless technology interfaces of devices. This has been done by Colin Mulliner. I think a few people here know him, maybe better than I do, because we never met, we just worked remotely together. And he has some Bluetooth device security database where we had the idea to generate hashes on the profile information, stuff like that, in order to tell which model this Bluetooth device is. So it's possible to tell the manufacturer, but not which model it is. So this would be important for security auditing. So I want to know which model is vulnerable to such and such attack. I want to do device statistics. I want to do automated application distribution via Bluetooth, so I have to know whether this is a phone with a color display or black and white display. So there is some reasons that would justify an application like that. And again, now there has been a paper released explaining all the details about blueprinting, and it's also a poll tool. It's also buggy, a little, but as said, it's nothing new to release buggy software. And that's the way how it is done. The hashing information from profile entries. Every profile entry which defines, okay, I can do that for you, I can do that for you, offering services to other phones, has a record handle and a RFCOM channel number, which the phone or the other device should connect to when using that service offered. So what we did is multiplication of the rec handle and the respective channel, adding multiplication and adding it all together. So we have a hash value which is easy to generate. So it also would work on really constrained devices. And then the other part which comes into the fingerprint or the blueprint is the Bluetooth device address. The first 3 bytes of every Bluetooth address is as for MAC addresses. Okay, I didn't switch it off yet. Okay, now, stop it. The first 3 bytes refer to the manufacturer. There's a list which is called OUI list, and it's published by the IEEE. And this is the other part of our blueprint. So what you see here is an example. And this is referring to a Nokia 6310i, I guess. I'm not sure. But you will find details in the paper published on tryfornight.org. And I'm glad to hand over to Marcel again. So that's for now.
Basically what we did so far was a text to badly implemented profiles, etc. But basically profiles are the applications. But they're also bad protocol implementations. Speaking of one of them, it's only the peak of that might come in the future. It's the L2CAP profile, the lower layer stack. And it has a signal channel and a data channel, as most protocols have. And the problem is the signal MTU is unknown. If you exceed it, you get an error message, and you get the actually MTU. Bad design, but worked so far. The L2CAP has also some kind of echo stuff, like a ping on TCP, on IP, and you can generate a buffer overflow or denial of service attack. I used the Hdi Dump, the Bluetooth sniffing, to demonstrate it. General, I haven't showed for earlier how Hdi Dump really looks like. In general, you have this is a command, it's outgoing, it's the HDI event, it's ingoing, so we create a connection first. We need to connect device. We create the Piconet. That's this above. Create connection, okay, command status goes back to some kind of flow control on the HDI, connect complete with a positive result. Then we do on the HDL data channel, we do L2CAP. We send an echo request with a length of 20 bytes. The length is variable, and you can send 0 bytes or send 2000 bytes or whatever. This is a supposed response. You get a number of completed packets. It's again flow control, and you get an echo response from the remote device. Generally, the idea is you send a number of bytes, you get the same bytes back. The specification says, okay, you can send, you can also repeat a response with 0 byte or whatever you want. Put some other string in it. You simply have to respond to echo response or say, okay, command rejected. I don't know that command. That's also relevant. So problem is, make this a little bit bigger. Say 2000 bytes. Let's say 60,000 bytes. What happens most times? The phone, the other device crashes because it's simple buffer overflow. They only handle most times only 48 byte, and everything that over 48 byte goes somewhere in the stack on the chip, and it simply crashes. Basically, we don't have an IPAC here, so an IPAC 2020, 2000 generation, 1900 generation. Someone are not afraid of getting it crashed? Make a fancy name. I think all names are already changed, because you know we scan again. Oh, scanning was already finished, now trying to resolve the names. In the other external, you will see the HI events going on. That's a simple name response. The name of a Bluetooth device is always fixed size, 240 byte, I think. So you can put some very crap in there. Normally it's null terminated, but the specification is a little bit of unclear there. So, where is the IPAC? Yeah, it takes a little bit of time because in a remote name request also means that you have to connect to that device. It's not a really connection, but you still have to page it, so you have to initiate a temporary connection to the device, and that takes time. Especially in a room where I think more than 100 devices around and visible. Sometimes the name request fails, that can happen. Still no iPack? Oh, Linux machine, nice. That must be another Linux machine. Have you seen your name so far? Very fancy.
Did anybody try to call this number?
Who is this? Or better, where?
You know, the idea of Bluetoothing is a little different than kissing.
Yeah, maybe we try that. Okay, 0, 0. Okay. Yep. And for 9. Okay, I'll shrink this window a little bit to see the Hdi dump. So creating the connection takes a little bit time. Okay, that's supposed to be it. Normal size, like we've seen in the Hdi dump, the previous slide. Now I try to increase the size. Sending only 10 packets and increasing the size to, what was the size the IPACs should crash? 700? Well, let's try, let's make 800. Yeah, the Linux tool has a little problem with too big sizes. When I have a little time, I have to fix that. So create connection, that takes a little bit. If you see the connect complete coming, then we are connected.
Oh, it's too big.
Or maybe it's too big. Yeah, I said the Linux implementation has a size problem. Let's try 700.
No, it's 600.
Okay, 600. I should know my own code. So, nothing coming back. We see this one big packet here, over there. And there's supposed to be in response. So on the iPack should be crashed. Can you do anything?
Wrong answer.
Are you sure? Okay, then maybe that's one of the iPads where only the Bluetooth part crashed. Because actually it's not really responding. Try
normal size now.
Let's try another size. Okay. Actually, but you already see the iPad responded slowlier than it's in the initial size. Maybe this device has a newer firmware where they fixed a little bit. Can't connect. Is it still running your iPad? I'd like to get another iPad.
Try a normal size packet again.
I can't. implementation problem. Haven't fixed it.
No.
No, just a
I
normal
may
size.
make a flood.
Normal size? Normal check.
Just a normal size to see if your stack's still running at all.
Oh. It says can't connect, so actually you see create connection and you see connect complete with not 00 in the beginning. I got a laser pointer. So you get a status back, so device is not reacting, we can't connect to it. So I think only the Bluetooth part is crashed if you can still use it. Can you scan? Okay, then it's one of the IPACs where only the Bluetooth part crashed. We actually did not really know what happens. Some assume, oh, there's a bad chip in there. Some, it's a stack. What the hell is that?
I'm sending him 60,000 bytes.
That looked wrong.
He may not be crashed, but he'll
I
be busy
crashed
for
my
a
own
while.
machine. Okay. Let's continue. Actually, there are IPACs around where you simply send a big packet and they go down. With a FreeBSD tool, you can send a very big packet up to 60,000. Oh, sorry. With a FreeBSD tool of L2Ping, you can send a very big packet up to 60,000, and then maybe crash easier. But we have seen also crashing it. And this attack is only one of them that really attack directly at the protocol layer and at the low protocol layer. You don't have to do OBACs, you don't have to do AFCOM. You simply send a little bytes. You can hard code it, and then the phone goes by sometimes. Maybe the IPAC goes by in this case, and yeah, there are other attacks like the SDP protocol. Maybe it's easy to attack that. And you don't need any authentication because it's a low-level connection. If the device is not in security mode 3, you always can do this if you know the address or the device is visible. Adam, will you finish?
Okay, so that's pretty much it. So the conclusions we've drawn so far are that Bluetooth itself is secure. Seems to be all the problems we found so far with implementation of the actual software sets that you connect to underneath rather than Bluetooth itself. We now have actually managed to establish some good communication channels with the Bluetooth SIG, and we're doing some pre-release testing at the Unplug Fests, which happen 3 times a year. So we're going to these events and actually attacking prototype devices, so hopefully they will find the problems before the devices hit the streets. Now, if you go to the bluetooth.org site and look at the details for the Unplugged Fest, you'll see that everything there is done under very strict NDAs, and so we're not allowed to discuss the specific devices that we've tested or the people that we work with at the events, but it's a start. You know, they are actually starting to look at those issues seriously and do something about it. The Bluetooth SIG at the same time are pushing to set up better channels so that the next time people like us come along from the open source world or from the outside world and say we found problems, that there are actual sensible channels that they don't have to spend 6 months banging their heads against a brick wall before the manufacturers pay any attention. So they are helping with that, and we should start to see the Bluetooth.org site becoming more useful in that respect. So that's what I was saying at the beginning. If you're thinking of looking at this stuff and playing with it, and you want to communicate with the manufacturers, that conduit should be available on the Bluetooth.org site fairly soon. They're also talking about potentially applying mandatory security requirements at application level instead of just within the Bluetooth specification itself. But I suspect that's some way down the road, given how long it's taken to even get this far. So Martin has set up a website, tryfinite.org, where we're publishing our stuff. There are other members who have joined since we started. Tri-Finite Stuff has the various software. You can go and download Bluver from there, and there's some other details on there, so go and check it out. We'll put the slides from this presentation on there. These are the current members. Tim Herman and Mark Rowe were the guys who did the range extensions, and they joined recently. I haven't met Spot yet, so I don't know who he is. So, if there's any questions? No? It's all simple. Come up to the mic, please.
You talked a lot about Motorola and other stuff. What's about Siemens handies? Have you some experience with them? Because they're very common in Germany.
Yeah, if you go to my original disclosure site is bluesnarf.org, and there's a table on there of all the phones I've tested. There were 2 phones from Siemens that they sent, which I tested, and neither were vulnerable, so they seem to be okay, the Siemens phones.
I'm sorry, but I just wanted to add something to the denial of service bits. First of all, the K700i from Sony Ericsson, it dies when you send an L2 cap ping of more than 4,934 bytes, I believe.
Okay.
And
We never tried that.
talking about Siemens phones, there is a pretty cute something with this S45. You know, this small one? Oh, that's my Nokia.
Lift it. You have it with you?
Yeah, actually, but I can't show you because the battery is finished.
Okay, I can see it now.
This one here. It actually dies when you try to delete, like through OBEX, try to delete a non-existing object twice.
Okay.
So it just switches itself off, which is pretty cute. And talking about unauthorized OBEX connections, that's possible if you take RFCOM channel 4. So
And do OBEX through RF?
no, you can't. You can't do a get or a put, but you can do a delete. No, it doesn't actually work. But as I say, if you delete a non-existing object twice, it dies. So hey, that's rhymes.
Right. I think it'll turn out there's lots of denial of services. There are some other ones known about in OBEX. I think it's either Pentest or another. What was the German company that published some stuff? There was another company published some stuff about crashing phones. I think they called it the Chaos attack, actually.
Use a microphone.
So we can't hear any of that up here. So.
Oh, it's the S55 and not the S45 as I just heard.
Okay, if there's no more questions, then that's it. Thank you.